Lesson 1.4 Absolute Value Inequalities. So last time we talked about absolute value. So what does absolute value means? Yes, if we indicate any absolute A, then it should be A unit from the 0. That's what this means, right? Okay. So it was kind of equation. So now we are finding inequality. Okay, one example. I want to make absolute x is less than 6. Then you need to know what this means. If it was equations, you may say x value that is 6 units from the 0. Now this one is inequality, so you have to do it. Any x value is less than 6 units away from the 0. Make sense? You know what I'm talking about? Yeah. So on the number line between 0 and I'm gonna make 1, 2, 3, 4, 5, 6. And there was a 1, 2, 3, 4, 5, 6. So based on 6 and negative 6, we know that these values are 1, 2, 3, 4, 5, 6 away from the 0 here. Okay? But now, other values. What other values would be less than 6 units? Any value between here, right? Think about that. We don't care the number is bigger than 6 or negative 6. We only care the unit value from the 0 is fewer than 6 units. They can be based on integer value, negative 5, negative 4, negative 3, negative 2, negative 1, and then 1, 2, 3, 4, 5, those values. Then it is true because, this one can be only 1 unit, which is definitely less than 6 units. And then 2 case also 1, 2, and then 1, 2, definitely less than 6 units. Therefore, whenever we indicate absolute x is less than 6, then this range become negative 6 and 6. Otherwise, this x value may be more than 6 units. So this x value must be between negative 6 and 6. Then what could be general form? So I'm going to make absolute x is less than a. Then this become x is between negative a and positive a. If expression is indicate as less than or equal to a, then this become x is between negative a and a inclusive, like this. Okay? Yeah, so please remember this setting here. Okay, it's very important. Now, what about, I'm going to assign the same numbers and same variable, but different direction. Like absolute x is now bigger than 7. Then interpretation. This means this x value is more than 7 units. Okay? So now just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then keep going, and then negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, and so on here. So based on equality or equation, now we can set up the boundary value, which is the negative 7 and 7 here, right? They are all 7 different units away from 0 here, right? And then similarly, any value between here, there will be less than 7 units from the 0, right? Okay, but we want to look for more than, greater than 7 units. Then this case must be this area or this area, which means when we count from the unit centered on 0, there must be more than 7 units. So we know this is 7 units, then there will be beyond the 7 units. This is 7 units, then there will be beyond the 7 units. So based on this truth, we can set up that. So if x is bigger than 7 units, then this become x is less than negative 7, or x is bigger than 7 basically. Otherwise, we cannot guarantee that particular x value is more than 7 units. So generalization. So if we have absolute x is bigger than 7, then this means bigger than a, then x is less than negative a, or x is bigger than a. If expression include equal sign, then it becomes x is less than or equal to negative a, or x is bigger than or equal to a. Okay, so that's the general concept of the absolute value inequality.